Good evening and Happy New Year to all of you. Today's class we'll see about waves and ray diagrams. I'll take you through how waves are described and why should you know about waves in physics, and also about the diagrams to construct. There are simple methods to construct the ray diagrams much more easily and accurately. We'll see about those methods in this class. Alright, now what are waves in physics? It's a way of energy transfer from one point to another. Now in higher classes you will learn about progressive wave, mechanical waves, etc. But here for IGCSE curriculum you need to know about those two types of waves. You might be already familiar with longitudinal wave and transverse wave. I'm not going to detail about because that's very basics. Now I'll give you a tip to remember the definition, where longitudinal starts with L and you have parallel also, because I've seen some of the students get confused how to describe longitudinal waves correctly. So you remember that LL, hopefully you will write the correct definition. Now here you'll be comparing two things. One is the direction of movement of the wave and the vibration of the molecules. So both should be parallel to each other. So how do you define a longitudinal wave? It is where the particles vibrate parallel to the direction of movement of the wave. Right? That makes a complete correct statement of longitudinal waves. Similarly for transverse waves, it will be perpendicular. So how do you frame it? Again, the molecular vibration will be perpendicular to the direction of movement of the wave. So both the terms are the same. Parallel and perpendicular terms alone will change for each of these definitions. And what are the examples for longitudinal waves? You have sound waves. So all type of sound waves will be longitudinal. And for transverse, you can remember all those 7 waves in the electromagnetic spectrum. Those will be transverse waves plus water waves. Alright, so any of those waves that comes from the electromagnetic spectrum will be transverse wave. For example, radio, micro, X-rays, gamma, ultraviolet, and so on. All these 7 will be transverse waves, plus water wave also is a transverse wave. Because in MCQs they might give you to identify what type of waves it is. If it is longitudinal, it's very easy. If it is a sound source, then it will be longitudinal, because it requires a material medium to transfer and so on. So I'm not going to detail about these types. You can read it from your textbook. I hope you will get an understanding from there. Now construction of these waves, that's very important, because that will score, or rather, common mistakes occur while constructing reflection or refraction or diffraction of these waves. Now, why do we have to learn about water waves when we are analyzing the electromagnetic spectrum is, now the waves in the electromagnetic spectrum, you cannot see it with naked eye, but then water waves have similar, or they exhibit similar properties as that of those electromagnetic spectrum. Hence, if you analyze the water waves properties, you can actually compare it with the electromagnetic spectrum of waves. Alright, so don't think only in water waves reflection, refraction should be occurring in such a way, but all these transverse waves will exhibit similar properties as that of water waves. Now, the properties that you need to know about is, as I mentioned earlier, reflection, refraction, and diffraction. I quickly go through the definition of each one of them. Deflection is when it bounces off, when the waves bounces off from an obstacle. Usually it's an opaque obstacle, and that is reflection. Refraction is the change in direction of these waves when it enters a different medium. Third, diffraction will be when it passes through a hole or a gap in an obstacle. The spreading out of the waves is diffraction. Now, again, in reflection of water waves, if you take, first of all, how do we represent water waves? We draw equidistant lines. Now what do these lines represent? They are called the wavefront. Wavefront is the line that's joining either the crest or the trough of the waves. As I said, I'm not going into detail about the theory. What you need to know for construction and for the IGCSE curriculum is what I'm focusing here. So these lines represent wavefronts, and the distance between two adjacent lines will be equal to a wavelength lambda. This you have to remember. Distance between two consecutive wave fronts will be lambda, and they all will be equidistant to each other because it is representing the wavelength of the wave. Alright. Now if you have a set of parallel lines or water waves that is approaching, first when we see reflection, say imagine this to be the obstacle. So there is an obstacle placed at an angle. Now how would the waves reflect is what you have to construct or draw. Now usually when you draw the direction of the wave, if you notice I've drawn a line that is horizontal, this is vertical. Now the angle between the direction of the wave and the wave front will always be 90 degrees to each other. This point you have to remember because that's very important for you to construct accurate diagrams. I repeat, the wave front and the direction of the wave, they both are at 90 degrees to each other. Right? Keep that point in mind. Now when, say if this is the direction of the light ray, direction of the water wave. Now as I said earlier, any transverse wave will behave very similarly. So if you imagine this to be a light ray, what happens at an obstacle, say it's a mirror, it will obey the law of reflection and it will reflect back. What is law of reflection? The angle between the incident ray and the normal should be equal to the angle between the normal and the reflected ray. Alright. Now how do I find the angle? The angle should always be at the normal should always be at 90 degrees to the surface. Correct? So this is the normal and this is your angle of incidence. Okay. Now this has to reflect by satisfying the rule. Now this angle should be equal to angle I. So angle I should be equal to angle R. It's clear. Angle I should be equal to angle R. As I said, the normal is at 90 degrees to it. Okay. Drawing the line is easy, but how do I complete the wave fronts? Now, if you take it to the mirror, you will continue. You cannot draw it beyond this because it's an obstacle, it won't travel beyond it. Now, this reflected ray, as I told you earlier, should make 90 degrees with the wave fronts. Okay. And another point to remember, will the wavelength change when it is reflected? It will not. The wavelength of these wave fronts or the wave will not change when it is reflected. It's going to be the same. So none of the properties will change except for the direction. How does it get reflected? By satisfying the law of reflection, I is equal to R. Okay. Now, constructing this wave front, so you have to keep in mind, you cannot draw the lines further away. Okay. You have to keep more or less the distance equal. So I don't have space. You can continue and show as many wave fronts as there are here in this as well, and see that I have drawn in such a way that these lines make 90 degrees to the reflected ray. Alright, keep that in mind. Now see here, by I have measured it and I have drawn it, but then I'll give you an easier way to find out or to construct any 90 degree line or perpendicular line to an existing line, which is, see the normal that I have drawn. I have seen many students, instead of drawing like this, they draw the normal here or at an angle different. They might not be able to judge it correctly. Hence, for those children, there is a tip here. If you take a ruler, you will obviously draw a ruler, use a ruler to draw the normal, right? Now, only a transparent one will work. See that the readings, the longer line or one of the longer lines here should match with the line that is already existing. Now see, I can keep it like this and draw. This will not be a perpendicular line. As I said, see there are readings, graduation here, there are thick lines, thin lines. Make sure one of these lines coincides with the existing line, and if you draw, it will be exactly 90 degrees to the line. So you have constructed the normal accurately. Similarly, here also when you are trying to draw these reflected wave fronts, keep the ruler so that this thick line coincides with the reflected ray you have constructed. Okay, I'll draw it separately and show you what I am talking about. So you have a reflected ray like this. If I want to draw accurately 90 degrees lines to these, then what I should do, one of these markings is what I'm talking about, these markings, all right. Make sure the markings, one of it is coinciding with the line. Now, if I keep it like this, it is not coinciding. Okay, adjust it so that the line is exactly coinciding with the line that is already drawn. Then, if you draw alongside, you will get perfect 90-degree line. So that's a tip for you to draw accurate diagrams, and keep in mind this distance has to be equal, so you can plot points and then construct it accurately. So this is about reflection of water waves, or it also applies to any type of transparent wave. It could be light wave as well.